Welcome back at C-Square. In this lesson we'll cover the square, which you notice we have a definition here. A square is a parallelogram with all four sides and all four angles congruent. What do we mean? Look at here. We can see that in the picture all four sides congruent, right? Because it's a parallelogram and we know opposite angles are congruent in a parallelogram, this is going to be 90, and consecutive angles are supplementary, so this is going to be 90. All these angles are congruent. Okay, 90 degrees. So all the property of parallelograms, rectangles and rhombi apply to the square. So for example, I said here the diagonal of a square bisect each other. If you remember, that is a property of the diagonals of a parallelogram. The diagonal in a square are also congruent because, like I said, square is a rectangle, so the diagonals are going to be congruent, and also the diagonals are perpendicular because a square is also a rhombus. So now we're going to use all these properties I mentioned for solving some problem. So let's take a look to this first problem. When we have a square, that is the meaning of this sign, square ABC, find the value of the variable, then find the side lengths. And if you remember, one of the property of the rhombus is that all sides are congruent, so I'm going to mark them on the picture. And now I can write some geometric statements like AD congruent with BC, which means the measure of AD is equal to the measure of BC, which obviously gives us this equation 3y plus 4 equals 2y plus 8. An equation. So the geometry, or at least in this moment, is reduced to an equation. I'm going to subtract 2y here to cancel these 2y. Don't forget to do the same thing on the other side. Then we have y plus 4 equals 8. One more step, subtract 4 to get rid of this 4. Obviously, you notice I subtract on the other side, and we have one variable. We have y equals 4. We need to find x, and for that reason I think you can go here and replace y with 4. 5 times 4 minus 4, and that will be 16. That means the length, the measure of DC is 16. But as you know, DC and AB are congruent. We can see that in the picture. So that means they have the same measure, which means AB, which is 3x minus 5, is equal with 16. So for finding the x, we're going to add 5. And we have 3x equals 21, and the last step for finding x is divide by 3. X equals 7. And the last thing was to find the lengths of the segment. We have DC, here it's 16, the others are the same, AB, BC, and AD, all of them are the same because this is a square, 16. On my next problem, we know ABCD is a square, and we know AE, it's 5 units, 5. We need to find the measure of DB, and DB is the whole diagonal here. And remember, this is a square, which means all these segments are congruent. So that is a property of a square, so 5 everywhere. So how much is going to be now dB? That will be nothing else than 10. So let's go to part B, where you need to find AD, and for that reason you can take, for example, this triangle where I mark the right angle, and these two legs are 5, and there are two ways to do it. The classic way will be to use Pythagorean theorem, a squared plus b squared equals c squared. A and b are the two legs, the 5, and we have 25 plus 25 equals c squared, which means c squared equals 50, which means c is square root of 50, which can be simplified, right? Because it's square root of 50 is 25 times 2. So I'm sorry, times 2 I said. So that means c, which is going to be 5 square root of 2. Remember, c is nothing else than AD. 5 square root of 2 is AD. Another way to find this one, if you learn special triangle, you should see this one as a 45, 90 triangle, and which tells you 5 and 5 square root of 2. If you did not learn that, then Pythagorean theorem. Let's take a look to part C, the measure of angle CEB. Let me erase these things here. CEB, this angle here, oh, well, that it should be simple. The diagonals are perpendicular in a rhombus, that is, in a rhombus also, in a square, this one is 90 degree. And we have one more thing, the measure of angle BAC, which is this angle here. This is a very interesting situation. Let's take a look a little bit. As you know, this angle here should be 90 degree. Okay, and let me erase also these guys. So now we are looking, let's say, to this triangle ABC, and we know this angle, I'm not gonna call it just B, and angle ABC is 90 degree. And remember, these two sides are congruent, so that means it's an isosceles triangle also. So this angle, which I'm going to call it X, and this angle are congruent, which I'm going to call it X. So now I can write what? The sum of the measure of the interior angle of triangle ABC is 180. Okay. So now we can solve for this, and we have 2x plus 90 equals 180. Subtract 90. So 2x equals 90, divide by 2. X equals 45. So that means this angle here is 45 degrees, which is a very important property for a square. All these angles are 45 degrees. Okay, and you're gonna see that, we're gonna prove that later. In the next problem, very similar, we have MN now, which is the side of the square. This is 30. So that means everything is 30 here, right? This one, RM, and also RP. And we need to find each measure, and one of them is RP, which is also 30, because in a square all sides are congruent, they have the same measure. PN also 30. RN, that would be interesting, we need to find out an TM. Okay, so let's take a look to Rn. Now, remember, this is 30, and we're going to use pretty much the same technique. So this is a right triangle, this big triangle. This is 30 and this is 30. We see that in the picture, and we need to find this C. So again, we can use Pythagorean theorem, and if you learn about special triangles, then you can use that also. So we have here 30 squared plus 30 squared equals C squared, and 30 squared is going to be 900. Another 900, that will be C squared, and that means C squared is 1800. And C will be square root of 1800, which can be simplified, right? That will be 900 times 2, and that will be 30 square root of 2. So that is the C, which is Rn. And now let's take a look to Tm. This is Tm, okay, which is the same of Rt and Tn or Tp, but very important, it's the same of, for example, Rt. So how do we get Rt? Rt will be half of Rn. So that will be 15 square root of 2. And like I said, Rt is congruent of Tm. So that means Tm should be also 15 square root of 2. And that is about this problem. On this one we have to use some algebraic skill, and also let's see what is about. Find the values of the variables for, and this is the meaning of this sign is parallelogram A, B, C, D. So be careful. Okay, but now let's take a look to the picture. This is a special parallelogram. It's a parallelogram that has two consecutive sides congruent. So that means it's a rhombus. Moreover, what kind of rhombus is this one? It's a very, very special rhombus. It's a rhombus that has all angles congruent, so that will be a square. Okay, so yes, we have a square here, and we know now angle 1, this angle, should be 90 degrees because the diagonal in a rhombus or square, in this case the square, are perpendicular. So we're gonna have the measure of angle 1 is 90 degrees. We can replace the measure of angle 1 with this expression given, 5y plus 30 equals 90. Subtract 30 here, and we have 5y equals 60 divided by 5, and we have y equals 12. So we did the first part, we find y. How do I find this x? If you remember, we have a property for these angles like this one here. That angle has a measure of 45 degrees. Okay, so we're gonna have here 6x equals 45 divided by 6, and that would be 9 times 6 is 45, right? Very similar we're gonna do for this angle here, because this angle also is gonna be 45. So I'm gonna write down here measure of angle ABD is 45 degrees because it's a square, so which means 9z equals 45 divided by 9, z equals 5. So we use the property of a square for solving this problem. Another problem where we have to use algebraic skills. We see some expression there. So let's see what is about here. Find the value of the variables. For parallelogram, again, it doesn't say it's a square. A, B, C, D. If AE is 3x minus 4, CE is 2y minus 1, and BD is 5x minus 2y plus 9. Justify your answer. That's very important. Okay, and let's take a look. What kind of parallelogram is this one? Again, we notice these two sides are congruent. We have a right angle. So again, this fact is a square. Okay, so now let's take a look. What do we know about AE and CE? These two guys. These two guys are congruent because, in fact, that's a property of a parallelogram. The diagonal bisect each other. But in fact, this being a square, also these two are congruent with the other two. But my first statement will be AE congruent to CE, and again the justification is the diagonal bisect each other, so AE will be equal to CE, so which gives me this equation 3x minus 4 equals 2y minus 1. Now we need another equation, right? And that comes from this BD, right? If you take a look, BD, it's nothing else than BE plus ED, which we can replace them with what? With AE and EC. They are the same measure. So which means BD will be 3x. I'm sorry, let's do it this way. Let's replace BD with the expression we have given to us, which is 5x minus 2y plus 9. So this is how much BD is. And now we have these two segments. So the first one is 3x minus 4, and the second one is 2y minus 1, right? Okay, so if we can simplify this one a little bit, maybe 5x minus 2y equal plus 9, let's say like this, equals 3x plus 2y minus 5. So now we have these two equations, but we have this equation, right? So I will suggest to bring x and y on the same side. So here I'm going to subtract 2y. So I'm going to get 3x, and don't forget we do that here also, minus 2y. And then I'm going to add a 4 here to get rid of this minus 4. And obviously add a 4 here. So we have this first equation. And let's do something very similar with the other one. 5x minus 2y plus 9 equals 3x plus 2y minus 5. So let's say we're gonna subtract 3x from here to move it here. Gonna subtract 2y from here to move it here, and then we're gonna subtract 9 and move it here. So we have here 5x minus 3x, that is 2x minus 4y equal negative 14. So now we have a second equation. We have a system of equation, which I can put it down here. The first equation and the second equation. The question is, how do we solve this system of equation? There are different ways. I will personally multiply the first equation by 2. That's the easiest way in my opinion. And we end up with the first equation is gonna become 6x minus 4y equals 6. The second equation stayed the same, and in fact I should have multiplied by negative 2, and then we have negative 6x here plus 4y, and then on the other side will be negative 6. And then we have 2x minus 4y equals negative 14. Now we're going to add these two guys because we cancel these gentlemen here, and we have here negative 4x equals negative 20. So x will be 5 because we divide by negative 4. And we have x, we need to find y. So you can go in any of these two equations, maybe in the second one, I guess. And we have 2x, 2 times 5 minus 4y equals negative 14. So this would be 10 minus 4y equals negative 14. And subtract 10 on both sides. And we have negative 4y equals negative 24. Divide by negative 4. So y will be 6. And that's it for this problem, where we use the property of a square. One more problem where we have a square. We can see that here the diagonal intersect at G. So I will suggest you to make a picture. Maybe it's going to help us to understand a little bit more what is about in this problem. A, B, C, D, and the diagonal intersect at G right here. That is G. If the measure of angle AGD, this angle is A plus 2B, that angle is 90 degrees. You notice I mark it like a right angle. So one thing I can say, it's A plus 2B equals 90. And if the measure of angle ABC, this angle, again this one I mark it a right angle, is a square. So we have 2A minus B equals 90. Find the value of A and B. And another system of equation, I will also multiply the second equation by negative 2. But again, it's not the only way. You can do it in a different way. So we have A plus 2B equals 90. The second equation becomes negative 4A. And I should multiply by positive 2. Okay. And minus 2b equals 180. Again, you notice the reason we multiply, we cancel the b's now. We elimination method, how it's called, and we have here negative 3a when we add these two equations. Negative 3a equals, no, this is positive, because Right, it's a positive for A, so we have 5A. Okay, not negative. Let's be sure about that. 5A equals 270. So we're gonna divide by 5 here. And we have A equals 270 divided by 5. That will be 54. And we need to find B. So we can go in any of these equations. Let's say we take the first one and we have 54 plus 2B equals 90. We're going to subtract 54. And we have 2B equals 36 divided by 2. B equals 80. And that is about this problem. Again, we use the property of the square. Now, sometimes you're going to have to classify quadrilaterals. So in this example, we have to determine if this quadrilateral MNPR, we see the coordinates is a square. Looking to the picture, it looks like a square, right? But that is not good enough. Just we need to prove it. So we're going to look to the slope of RP, and that one is a rise of 1 and a run of 1, 2, 3, 4, 5. So like I said, 1 over 5 is going to be positive because it goes up from left to right. The same thing about MN. We notice we have the same situation. The run is 5, rise is 1. So now we know these two sides are parallel because they have the same slope. Very similar we're gonna do for RM and PN. You notice they have the same slope. I'm gonna write that in one statement. The slope of RM is the same of the slope of PN. And what is that? If you take a look, is the rise is 5, the run is 1, is going down from left to right, so negative 5 over 1 or negative 5. So again, that allows us to say that RM is parallel of PN. So we know PN, we know in this moment that this quadrilateral is a parallelogram. Okay, but also if we take a look to the slope of RM, for example, and RP, for example, they are negative reciprocal. So when you multiply, you get negative 1. So that means we have a rectangle here, because this angle here will be 90 degrees. A parallelogram that has a right angle is a rectangle. So what else we need to have in order to prove this one is a square? We need to look to the length of these two sides, and if you notice, like I said, in either one is 1 and 5, so we have 1 square, that is 1, plus 5 square, which is 25. Each side here will be square root of 26, square root of 26. So now we know, let me go here, we have this MNPR, a rectangle. We prove it using this coordinate proof. And also we notice that RM and RP, they have the same measure, which is square root of 26. So based on these two things, we know now M N P R is a square. Okay. So again, the first part we prove that is a parallelogram, then the second part we prove that is a rectangle, and finally this rectangle is in fact is a square because it has two consecutive sides, congruent. And this is the last problem in today's lesson. We need to write a proof, and this is kind of a way to prove all the property we mentioned in a square. We know here that ABCD is a parallelogram, right? If you remember what a parallelogram is, these two sides are parallel and these two sides are also parallel. Okay. We know that AC is congruent to DB, so this parallelogram is a special parallelogram for which the diagonals are congruent. Oh, that means is a rectangle. And also we notice we have angle AEB is 90 degrees. Okay, I'm sorry, AEB is the other angle, but that one will be also 90. So the diagonals are perpendicular. Oh, that will be a rhombus. So this is the idea here. We know this one is a square, but we need to write a proof. The proof is going to be a little bit longer, but I think it's worthy to do it and see how you can prove what I mentioned about parallelogram, rectangles, rhombus and square, this relationship. So let's start from the fact that we have a parallelogram. And this is given to us, right? Based on this thing, on this given statement, what do we know about the diagonal of a parallelogram? They bisect each other. So you notice here I mark them different because I don't know if they are equal yet. So I'm going to say AE congruent to EC. I'm going to put a box here, and I'm going to write here diagonal bisects each other. Okay, and also DE congruent to EB. Diagonal bisect each other. Okay. But then let's take a look a little bit, and this will be another arrow here, to this next statement given to us, which says AC congruent to DB and there it's given. And now if we take a look, based on segment addition postulate, we can say AE. In fact, the first thing I'm going to say here is if they are congruent, they have the same measure, right? AC equals of DB. Which is the definition of congruent segment. They have the same measure. And now let's take a look. AC is the sum of AE and EC, and DB will be the sum of DE and EB. But if you take a look, and this is the segment addition postulate, like I said. Okay, but if we take a look, AE and EC are the same. We have that here, right? And DE and EB are the same. So probably we could have write one more statement regarding the measure. But based on these three guys, we can say 2AE, because we do substitution, equals 2DE. And then obviously we can say AE it's equal with DE and that will be division property because we divide by 2. So now you notice we prove in fact that beside the fact that diagonal bisect each other because it's a parallelogram, those segments are congruent. All these 4 segments are congruent. So now I can kind of go back here. Let me change the color and mark all these sides the same because they are congruent. We prove it now. We know that. Okay, so now knowing this, I can start the second proof, and I'm gonna prove this is a square, but I'm gonna look first to prove that we have congruent sides like this to this one. Okay, and let's say this one. It doesn't matter, right? So we're gonna look in those 2 triangles, ADE and ABE. So if you notice, and let me erase first these guys because I don't want you to get the wrong idea. We're gonna prove that. You notice we have on that triangle we have AE. In fact, we have DE congruent with BE and or EB, and you see we did that here, so it's the same thing, diagonal bisect each other. And also we have AE as a common side. Okay, so you remember that is the reflexive property. And these angles also are 90 degrees. So we have 2 right triangles. So based on these 2 statements and because we have 2 right triangles, we can say the triangles are congruent. Triangle AED congruent of triangle AEB. Of course, probably I should write a short proof about this angle being 90 degrees, AED and AEB. And that will be the leg. Remember we have a right triangle. Of course you can use side angle side if you want. Okay, so based on that statement here now we can say AB congruent of AD. And that will be corresponding part or congruent triangles are congruent. And now we know this is a parallelogram, so obviously, yeah, if these 2 sides are congruent because they're opposite sides, but then everything is congruent. So, but that doesn't tell us is a square yet. It tells us is a rhombus. So what else we need to do to prove that this guy is in fact a square? We're going to take a look again to a small triangle like this one here. And these two angles are the same, right? This is an isosceles triangle. So that's my next thing to look to, the triangle AED, or you can do AEB, it really doesn't matter. And in that triangle we have the measure, and let's do this one because we already know this is 90 degree. Measure of angle AEB is 90 degrees. That is given. Then we know AE congruent with EB. And that one we prove it right here, right? So I'll say here proved. Based on this one we can say these two angles are congruent now. Isosceles triangle, like I said. The measure of angle AEB is the same with the, not AEB, I apologize, we already have that. The measure of angles EAB plus the measure of angle, I'm sorry, let's write first the statement that these two angles are congruent. And EBA. Okay, so they have the same measure. And the reason is property of an isosceles triangle, right? Okay, and now based on these two guys, we can say the measure of angle AEB plus the measure of angle EAB. And in fact, let me write that here better. The sum of the measure of the interior angles of a triangle is 180, right? And this is a theorem, right? The sum of interior angles is 180. So now based on these three things, yeah, it's a long proof. I'm gonna do a substitution. Do you remember these two angles are the same? And in fact, let's do that here. Let's do the substitution for the angle AB also. So we're gonna have 90 degrees, right? So plus twice the measure of angle EAB equals 180. Okay, so that will give us, and this is substitution property. And that will give us the measure of, I'm gonna make it like a shortcut, is from here is nothing here, then nothing else than algebraic property we can use, which is subtraction of 90 and then divided by 2, and that will be 45 degrees. And probably the last thing will be here, division property, because that's the last thing we're gonna do. Okay, so let's take a look. That means this is 45, this is 45. That means we can do that for all these angles. So now, one last thing you can do is to add any of these two angles and say it's 90 degrees. Okay, and then we know it is a square. So just probably put like this, the measure of angle BAE plus the measure of angle EAD will be 90 degrees, and that will be angle DAB if you add these two angles, and that will be the angle addition postulate. Unfortunately, I ran out of space here, but that is the idea of this proof. Now we see this angle is 90, the sides are congruent, is a parallelogram. So yes, now we know from all this that ABCD is a square. If you enjoyed this lesson, don't forget to click the like button and come back and see Square for more help. Thank you.